Welcome to qnawire.
Everyone, here it is given wooden cart having the mass 5 kg is pulled by the rope passing over the pulley. Static friction between the cart and the surface is 0.5 and kinetic is 0.4. We have to find the acceleration if tension developed in the rope is 300 Newton and B 400 Newton. There is no friction in a pulley. Let us start solving it. We have to draw the free body diagram. Its weight mg will act vertically downward. We have to resolve it into its component. So it is mg cos 20 mg sin of 20. Here it is tension. So T cos of 50 and T sin of 50. Now n minus mg cos of 20 plus T, normal reaction will be here. T sin of 50 must be 0. So and you will get mg cos of 20 minus T sin of 50, and for stationary there is a static friction mu s into n, that is mu s mg cos of 20 minus mu s T sin of 50. T minimum required to move the card, so it is equal to minus mg sin of 20 plus T cos of 50 minus mu s mg cos of 20 plus mu s T sin of 15 is equal to 0. So T minimum required to move the card over the inclined plane will be mg sin of 20 plus mu s cos of 20 upon cos 15 plus mu s sin of 15. So T minimum we can calculate. Mass is given 5 into 9.8 sin of 20 mu s is 0.5 cos of 20 upon cos of 15 plus 0.5 sin of 15. So it is to be equal to 363.56 Newton. So minimum tension required is this. So in the first case acceleration is 0 because tension is less than minimum tension required to move it. But if tension is more than T minimum, which is given 400 Newton, so equation of motion will be minus mg sin of 20 plus T cos of 15 minus mu k mg cos of 20 plus mu k T sin of 15 is equal to ma. So acceleration you will get minus g sin of 20 plus mu k cos of 20 plus t cos of 15 plus sin of 15 upon m. So now substitute the value. G is 9.81 sine of 20 plus 0.4 cos of 20 plus 400 cos of 15 plus 0.4 sine of 15 upon 5. So it would be equal to 1.513 meter per second square. That's all. Thanks for watching it.